Thank you. Welcome, everyone. Thanks for joining the WebEx today. My name is Dan Mikusa, and we're going to talk about Tomcat 8 today. So we have a short little agenda here for you. We're going to get started with some introductions. We'll talk about the Java EE7 spec and how that impacts Tomcat 8. And then we'll talk about some Tomcat-specific changes and the time frames when you can expect to see some of these things in practice. So to get started with introductions, I'll talk about myself first. My name is Dan Mikusa, and I am a Senior Technical Support Engineer at Pivotal. So I help our customers with Tomcat and TC Server issues, as well as things on the Spring Framework and Cloud Foundry. I've also posted some articles on Tomcat Expert, and if you're on the Tomcat mailing list, you've no doubt seen some of the posts that I've had there. Our other presenter is Stuart Williams, and I'll let him give you a quick introduction.
Hi, everybody. I have been active on the Tomcat users list for around 12 years now, and I've been a user of Tomcat since 3.3. At Pivotal, I've been a SME in the consulting team for Tomcat Server, and now I'm a lead software engineer for the T project.
All right, thank you, Stuart. So with that, we'll move on and talk a little bit about the Java EE7 spec and what parts of that Tomcat implements. So if you've used any versions of Tomcat in the past, you'll know that Tomcat does not implement the full Java EE spec. It implements just a subset of that. And in the past, it's been the Servlet, JSP, and expression language specs. With Tomcat 8, it's also going to include the WebSocket spec. So you can see the version numbers that are included with Tomcat 8 here. These subsets of the spec are just the ones that the Tomcat developers have deemed the most interest in. It's just kind of a core set of the specs that you can use to publish web applications. If one of the specs that you need is not included with Tomcat, you can often include that. If not, there are actually a couple more full containers that you can use. There's the TomE project, which implements the web profile, and there's the Apache Geronimo project, which is a full J2EE container. So the first spec that we'll talk about here is the Servlet 3.1 spec, and this is fully implemented in Tomcat 8, and the spec went final in May of this past year. It's not a huge jump from the 3.0 spec, but it does add some nice new features. The first one of those is the non-blocking I/O support, and this is a couple interfaces that were added that allow you to more easily, more streamline just requests that are I/O bound. So if you've got something that's reading from disk or reading from a database, you can use this new interface to more efficiently deliver your content. In addition to that, there's support for an HTTP upgrade, which is part of the underlying support for WebSockets. So this was added. There's also support for a session ID, a method to change the session ID, and then also an interface where you can listen for changes to the session ID. Some other minor improvements in the spec. There's clarification regarding uncovered HTTP methods, and this is just really kind of minor, but it's important just to make things as clear as possible. There are also some other minor changes like that and some typos. So the change session ID support is two parts. The first part is a method that was added to the request object. It's a change session ID, and you can call that to change the session ID if you need to explicitly do that. There's also a listener, the session ID listener, And you can either implement that or use the @WebListener annotation to basically be notified when the session ID changes. So there was a clarification in the spec which regards uncovered HTTP methods. So in the past, it was a little ambiguous as to what would happen to those. They've taken a step to clarify that, and essentially what that says is if it's not listed, it's not covered. And I have a couple examples just to further clarify that. In this example, we've got a URL here, and we're specifying that the GET method is there. And essentially what that means is the only thing protected is a request to that URL with the GET method. So if you were to send a POST method, that would not go through the same security constraints that we see here. Here's a similar example using annotations. And this time we've got the GET and POST methods covered. So we'll know that both of those will be protected. But if you were to send a put request or a delete request, that would not be covered. So I have a couple demos here with some of the Servlet 3.1 features. I'll just start out by showing the web portion here. We're going to start with the non-blocking I/O demos, and it's from the user end. You don't really see a whole lot of difference. This particular demo here is just going to return "Hello World," so we can see that that's what we're getting from the server, but it's using the non-blocking APIs to do that. I've got a similar one here where this will just kind of echo back whatever we enter. And again, from the user side, you don't really notice a whole lot, but it is using the non-blocking APIs. One more quick one here. This one is just going to return back a bunch of random characters. And now the more exciting part of that, let's take a look at the code. So the first one that we looked at was just a simple hello world. And you can see here in the code that we've just got our basic servlet, and we've got our do get method where we're going to handle that get request. The first thing that's worth noting here is to work with non-blocking APIs, you need to use an async context. So in this case, we start that up. And then the next step, since we're just writing here, we're just going to register our write listener. And the write listener is the new interface that was added, which enables non-blocking writes. And that consists of two methods. One of them is just your basic error handler. And this would get called if there was an error that occurred, while information was being written to the user. In this case, we're just printing the error, but you could handle that any way you like. The second method is onWritePossible, and what that method is going to do is it will get called by the container when there's information, when it's possible for us to write information. So inside of this call, because the container told us that we're able to do that, we can just start writing. So what we do is we get the output stream. This is not entirely necessary here, but it's just checking again to make sure that we're ready, and then we're just writing to the output stream. Here we just do some basic cleanup, and that's it for the basic Hello World servlet. As you can see, this is definitely more code than a Hello World servlet using the traditional APIs. So that is definitely something to think about, when considering using these non-blocking APIs. So next, we'll just take a look at the Echo servlet here, and this is actually the second one that I had demoed. And as you can see, for as simple of a servlet as it is, just to read and repeat someone's entry, this is quite a bit more code. I like to compare that to what the traditional APIs would be, which, as you can see, is quite a bit less code. So again, it's important to think about, when you would want to use these APIs, when it makes sense, because there is an added complexity and development cost that goes with those. Just to walk through this Echo servlet here real quick. You can see at the top we're just handling our normal servlet stuff, and then what we're doing is we're creating this echoer object. And in this case, the echoer object is going to implement both the read listener and the write listener interface. And the write listener interface is the one that we talked about previously. The read listener interface is the other non-blocking I/O interface that you can implement, and that takes care of reading information in a non-blocking fashion. That one consists of 3 methods. There's the same error method, but in this case, since we're implementing both, we just kind of share that same error handler. And then there is a onDataAvailable method, and what that does is the container will call that method when data is ready to be read. So we know here in this code that the container called us so that we can start reading. So we set up our loop here, and we continue to read data. And in this case, what we're doing once we get the data is just for some statistics, we're going to count how much data was read, and then we're either going to turn around and write that data back, or we're going to buffer it. And which option we do just depends on the status of our output stream. So if the output stream is capable of writing at the moment without blocking, then we'll go ahead and do so. If it's not, we'll just continue buffering. The other method that comes with the read listener interface is this onAllDataRead method, and essentially that gets called by the container once all your data has been read. So it's pretty simple to understand. In this case, what we're doing is we're just going to log some statistics, and then we're going to have one last call to our write method just to make sure that anything we had buffered has been written out. Here we have our onWritePossible method, and this is just where we're going through and then actually writing out the information. So again, this all works. It's great. It works in a nice, non-blocking fashion. But as you can see, to implement something as simple as an echo, it takes quite a bit more code. One last example here, and this is slightly more involved. Let me show the web demo first. This is just a simple example of using the browser's server sent events API. And what this does when we click this button, we'll start listening for events from the server. And it's basically just a stream of information that's coming from the server. And in this case, it's just sending us timestamps every so often. What happens on the back end here, I'll show the code, is that we have our servlet. And just like the other ones, we're initializing that with typical servlet methods. Here we've got some some initialization and cleanup logic, and then here we've got our normal handler for GET requests. Again, because we're using the non-blocking APIs, we're going to create our async context. We're going to start it up, and then we're registering our listeners. In this case, we're just going to register a write listener because all we're doing is streaming data from the server. So again, we've got our write listener that we've built down here. In this case, what we're doing is we're just implementing this onWritePossible, and we're taking information that was generated. In this case, it's generating those timestamps, and we're just writing them out using the format that's required for the server sent events. That's what this is here. This data key tells the browser what information is being sent. So this is a little more involved example, and I'm not going to go through the code any further, but it's something that you can check out. We have a link for the code in the slides, and it gives you something that's maybe a little more real world to use these APIs for. Okay, so the next spec to talk about is JSP. And with Tomcat 8, we now implement the JSP 2.3 spec. and that turned out to be really easy because it's just a maintenance release, and there's basically no changes to it. There are some very minor things, as is documented here, but for all intents and purposes, it's just kind of revving the version numbers. The expression language 3.0 spec is actually quite a big change. There are some significant new features that were added. Fortunately, with the big change, there's not too many incompatibilities. There's really, as far as the spec says, there's really only this one that I've listed here at the bottom of the slide. So, for the most part, if you have, JSP code that's using expression language, when you upgrade, to 3.0, you really shouldn't see too much breakage. There might be some minor, this minor point here that's mentioned, but in general, things should just work. Once you do upgrade, you can see there's a bunch of nice new features that you get to play with. The big ones are the collections API and Lambda expressions. And then there are some additional new operators like string concatenation, the chaining operator, and the assignment operator. And these are all things that, if you've worked with the expression language in JSP in the past, you've probably hit them and said, oh, I wish I could do that. And so they're kind of nice things to see coming in the spec. So I'm going to go ahead and show a couple of those off here. Start out and show this little page I put together here. Essentially what it is just a little expression language evaluator. And you can type in your expression language code here, and then press the run button, and it will just go ahead and evaluate that for you. And then I've got some, pre-generated expressions that you can use for testing things here on the right. Before I get into this too much more, I'm just going to show the code for that real quick. You can see how that works. Basically, it's just one single servlet, and the web page is posting JSON data to it. And basically what we're doing here is we're just reading that data, and then we're going to go ahead and evaluate it. And to evaluate it, the code uses this new concept, which is an additional feature in the expression language 3, and it's this EL processor. And with the upgrade to the expression language, one of the things that they added is the ability to embed the expression language in other things. Previously it was used in JSPs, but with this you can now embed it into pretty much anything that you like. So in this case, what the servlet's doing is it's creating its own processor and kind of embedding it in the servlet itself. So we create the processor, and then what we do is we just add some kind of fun stuff that you can access through the expression language. We add this output stream here so you can write things, and we had this fake bean that we create here, and then we import some the date class so that you can use that as well. The heart of this is just right here, where you're just calling eval and evaluating the script that was sent to it. Not the most secure thing, but this is just a demo just to show off this feature. So if we go back and take a look, we can see that we can run a command, and then we'll get the result of that command here. There's a couple more just examples, and these are just essentially using the literal declarations for sets, lists, and maps, and you can see the output of them below. As I mentioned before, there are quite a bit of new features. Some of them are just nice new things that you can do. There are things like assignment. If we run this, you can see it just prints hello world, but what's important is we can see that it actually created a bean in our context, in our expression language context. So we now have this test that we can reference. There's a concatenation operator, which does pretty much what you'd think. You can now access static fields and static methods. And the streams API that I mentioned allows you to basically take your collection and start a stream on it. And that in itself isn't really a whole lot. You can see you just get this kind of weird stream object that comes back. But with the stream API, you can then do fun stuff like filtering, taking distinct list of items, sorting, and all sorts of things like that. And I'll talk about that a little more in a second. This one here is just to show you that you can also use the Streams API on a map. So it works for lists, sets, and maps. And in the case of a map, you just have to use the entry set method to get things going. So as I mentioned, the Streams API supports all sorts of different operations. We've got a map operation, a flat map operation, a distinct operation, sorted operation, sorted with a comparator. And as you can see here, the comparator is being specified using a lambda expression, which we'll talk about more here in a minute. There's a for each operator, which basically allows you to iterate through each item in the stream and then do something. And again, this is specified with a lambda expression. What's important to note about the for each is that it's a terminal operation, so this would effectively end the stream here. The peak operation is similar to the for each operation, except that it's not terminal. So you can run this code, but then the stream will continue on essentially like this never happened. There is also a limit operator, a substream operator, a reduce operator, min and max, average, sum, and count. And those are all just the basic operations that you can use. There are actually a couple more. There's a any, all, and none match, and those are just logical things. So you can say, do any of the items in the stream match this? Do all of them match this, or do none of them match this? And then lastly, there's a find first, which simply returns the first item in the stream. So the last neat new feature that they've added are the lambda expressions. And the lambda expressions are pretty simple. You just have this arrow operator that you use, and you can pass an optional argument to that arrow operator. In this case, we're not passing one. All we're doing is just calling this, and since it's set to statically return 64, we'll get 64 back. A little more complicated here. We define this lambda expression, which is just going to increment the value by 1. So we've got our argument x. It's going to return x plus 1, and then this portion here is where we're just calling that. So we're calling it with 1. So 1 plus 1 should be 2. It's also possible to specify multiple arguments. So here's an example of using 2 arguments. As you can see, once you've gone past one argument, you need to use a parentheses around those arguments. So in this case, we've got those around the x and y. Calling it is similar. You just pass in your values. One of the features that I like personally is that you can pass lambda expressions to your own custom beans. So if if you want to make integration easier for your developers that are writing the JSP, you can actually add support for that in your own beans. In this case, we have this pseudo person object, and we added this method can drink. It takes a lambda expression that we're passing in, and then it gives us a result depending on that. If we change this to something else, we can see that it changes the result based on the lambda expression that we've given it. A couple last notes. You can assign lambda expressions. So in this case, we've got our lambda expression, and it's being assigned to this factorial. Then when we run this, it can be like that. And then lastly, you can nest your lambda expressions. So we've got this inner lambda expression here, and this outer lambda expression here. And then we're just sorry, this is the inner one here, and you can see we're calling it with X. And here is your outer one, and then we're calling that with 4, which gives us 64. So these are some of the new features that were added in Expression Language 3.0, and I think you'll agree it's a nice improvement just to kind of make life easier for the developers. So with that, I'm going to hand things off to Stuart, and he's going to tell you guys about WebSockets and some of the internal changes with Tomcat.
So hi everybody. So thanks Dan. So WebSockets is the second significant the spec. WebSockets is a feature, a subset of the HTTP APIs, and it enables a type of messaging over HTTP. So I'll explain a little bit more about how the mechanism works and do some demo and show some code examples of how the APIs are wired in for a servlet container. WebSockets has produced a fair amount of debate about how encoding and decoding of the payloads occurs, and it's actually something that the spec doesn't clearly define. So it's possible to send strings or byte array blobs across the wire. It's up to you really to do the decoding. The spec is most conveniently implemented using annotations. That's what I'll show you today. And even though it's possible to build WebSocket components using the programmatic API, it's quite cumbersome to do that, so I wouldn't usually recommend that. WebSockets as a technology was supported in Tomcat 7. Its implementation was blocking within a frame because of the way the HTTP connectors work, but the actual spec and the way it's implemented in Tomcat 8, because of the support new connectors, means that WebSocket 1 is Tomcat still does have the has the blocking I/O connector, and the WebSockets API work with that. But that's one of the reasons that the Neo connector, the non-blocking connector, is now the default. So the WebSocket handshake is an HTTP upgrade, as I mentioned earlier. So the initial connection to the server sends the standard get path HTTP declaration, and then a header, a pair of headers even saying that the client wishes to upgrade to a type WebSocket and that the connection should be upgraded. If the server supports this, it returns the HTTP 101 switching protocol status with the matching upgrade headers. And at that point, both client and server switch from standard HTTP to bidirectional messaging. And these connections can be persisted for very long periods. And because the API mechanism that supports it is non-blocking, it's very low overhead to keep the connections open. And both the client and the server can send messages at any time. So there's an opportunity there for the server to send push events up to the client. Apart from internal support for ping-pong type connection status checking, the other significant thing to bear in mind is that typical for the connection and the server to force a close control frame. So I'm going to dive straight in and show you the code example. Before I do that, I should explain the mechanism we use to wire WebSockets endpoints into the container is slightly different than the conventional approach with either XML or annotations for servlets. We use a servlet container initializer. We recommend using a servlet container initializer to register the endpoints. The servlet container initializer either on every application context if your classes are on the main class path of the container, and then that's wired into every child context, or if you've got this code in your application context, it'll only be wired into that actual individual application. This runs before all of the context listeners, so it's the very first thing that runs. The servlet container initializers need to be wired in before any other components. And in fact, Tomcat's implementation of the WebSocket support is a servlet container initializer itself. Once this starts up, the SCI component for the Tomcat WebSocket support provides a servlet context attribute, and it gives us access to the server container. The server container is the WebSocket's official API for accessing the server, and it's as simple as then using the add endpoint methods and pointing it to the class define. We can pass in both a class and a server endpoint configuration. So I referred earlier about the programmatic API, and the server endpoint config is the mechanism for defining that. But as I say, I normally recommend using just the classes and the annotations, and this mechanism is the one I'll show you now. So your endpoint is a simple POJO, and it's annotated with server endpoint, which is very similar to the servlet annotations that specify the HTTP path. And remember, we make an HTTP connection first using a path, which means that we can have multiple WebSocket endpoints provided. In the path here, you can see that we have a variable defined, and that variable is now accessible wherever we can see the session object, the WebSocket session object, as one of the path parameters. So we can, in fact, pass in both path parameters and query parameters onto the end of the HTTP request, which means that your client can make different types of requests into the same endpoint. The first annotation we see for a method is on open, so that's in the sequence of ordered events on the channel. Remember, it's a messaging pattern here. So we have an open connection followed by the on message events for each message that we receive, and there's also on error and an on close annotation, so we can see a full life cycle of a WebSocket session. The second endpoint I've got to show you here is the mappings endpoint, which has all of those annotations placed in there. And I'll run this one in a minute as part of the example. I'll show you that one. I'm just going to comment this one out because it's got the same path. And the example I've built for this demonstration in the executed endpoint uses the standard Tomcat JMX API. And so we look up an MB in the executor for the thread pool in the application JMX API, and over WebSockets, I'm going to send a request for a specific attribute of that MB. So I'm going to ask for the size of the thread pool and a number of other parameters, and return that back as a simple string payload. That's sort of a little bit like a JSON string, so that can be passed by JavaScript. So let's run that now. It's going to boot up a server, and you can see, I'll show you the unit test in a second. It's made the requests, and it showed the value for each of those. I have the WIP for this page, so I can continue to make a request for each one of these. And you can imagine that in a more real application, being some JavaScript that's polling and making requests, or maybe the server is pushing status changes up, so that you could draw a chart on a web page of how active the thread pool was, perhaps. And you can see the 3 requests I made there are now listed in the log file at the bottom there for the inputs. So the other thing to note about the WebSockets API is that it comes with both a client and a server. And in our unit test here, I've started an embedded Tomcat on port 8081. That's the Tomcat's own servlet container initializer that starts at the WebSocket support. There's the initializer that I showed you a few moments ago. And then this is a standard JUnit test, so we have the test method. And there is a static finder method to get the WebSocket container. And we are able to use that WebSocket container to connect to the server using the WS prefix on the URL. It signifies that the URI is a WebSocket connection. And once that session's opened, we can assert true that the session's opened. And I've just got a little message handler here defined using the client API, which says for the whole message as opposed to a part of the message, which would fire several times for each part, that we can see the output. This is asynchronous in the rest of the flow, so we're going to define this now. And then when I send these requests, each for the attribute on the mbeam, I should get those answers back. And as we see, we did that. Those values defined there on the response from the output method. The POJO here, you can see I've called the onOpen method foo in this case, and on case. The POJO is proxied by a parser for the server endpoint. So you can pretty much define the method as any name you like and with any set of parameters from the available ones. So we might not need the set if we want, and you can also provide for other pieces of information on the WebSocket channel. So moving on from WebSockets to some other specific changes in Tomcat 8. There's a new set of features for publishing resources through Tomcat web applications using aliases and virtual directory contexts. These enable, amongst other things, the ability for you to place external content mapped into the URL namespace of a given Tomcat application. And there's additional support for the Servlet 3 resource jars. So it's possible, for example, to include JavaScript and CSS static resources inside a jar and have them published by the container. Tomcat 7 implemented the various components listed at the top there in a slightly different way to Tomcat 8. It was a little bit fragile, and there was an attempt during the development of the spec to rationalize this, and it was called overlays, but in fact this was dropped by the expert group. So Tomcat remains with its upgraded version of the implementation, but it did get dropped from the spec. I'm just going to skip this one and show you straight the XML so you can see some context to how these are mapped in. So for the application context, we say that there is a resources block defined, and the pre-resources are a file resource set pointing at a directory there that maps a specific file here rather than a directory, and that is resolved prior to the web application's servlet component. So a servlet attempting to serve that URI would never see that request. The post resources, of course, then for obvious reasons, are resolved directly after the servlet if there's no response from the servlet for that URI. Another addition to Tomcat 8 is a rewrite valve, very much like mod rewrites in the Apache HTTP server. This is a convenience more than anything else. The Tomcat user community has asked for this kind of functionality for quite a long time. It's been thought that adding an HTTP server just to be able to do redirects in front of the application is a little bit excessive. So this valve allows you to configure that in both server.xml and any of the context.xml files that you can place for your application. Additional changes now, as Dan mentioned, Tomcat 8 container requires Java 7 or later. The Neo connector is now the default. The non-blocking IO connector is the default. Information in the manager, the JMX APIs have been cleaned up and are a little bit more descriptive. Some of that may get backported to 7. We'll see. And a recent addition to the container is the Apache Commons database connection pool. Version 2 is now the default JDBC pool. And of course, the prior DBCP and Tomcat JDBC, Tomcat specific JDBC pool are still included as well. So if you've got applications that are using either one of those, you won't suddenly find that those classes are missing. The unclosed input stream tracking is an addition to the leak prevention features that were first presented in Tomcat 7. These aim to spot when your application or some component of your application, perhaps a framework library that you're using, is misbehaving and is not closing resources that it's using. In this case, we're seeing an addition of input streams are no longer closed. And these types of things are a problem for application redeployment. So if the application has not closed its resources properly, the web app class loader that wraps it can't be unloaded by the garbage collector. And so you've probably seen this type of thing where you're doing redeployment of the application and the permgen memory doesn't decrease and can increase for each deployment, and eventually you end up with an out-of-memory exception. So Tomcat 8 implements the Java EE7 specification that shipped last year. The 8.01 beta is available. The 8.03 beta was voted on and passed the vote, so it should be released within the next 24 to 48 hours. The implementations for each of the specifications are complete, but now we are in the phase where the container is undergoing user testing. Effectively, it's an open source product, so the more you use it, the more stable it becomes. There's already been quite a lot of interest in Tomcat 8, so there has been some great community feedback, and the developers have been able to fix a number of small bugs from various things like regressions from struts, applications to recent changes to the DBCP stuff. And when will it go GA? It's pretty hard to say at this point, but the guys think that May this year is probably a safe bet. And that's the end of my part of the presentation, so we'll start to take some questions from now on in.
Excellent. Thank you, Stuart. And it looks like Daniel's done a great job of addressing some of the questions in the chat. Excuse me, already. So I think there's one question that's worth repeating though. Camel asks, wouldn't it be more convenient instead of a write listener just to accept an input stream, which Tomcat would send on its own, similar to JAX-RS? If it's not in the spec, would you provide such an implementation of write listener in Tomcat on top of the spec? And Daniel responded a little bit about how Tomcat's kind of driven by the specs, and I was just wondering if you wanted to add any more to that or expand on it a bit. I thought that was a good question.
Yeah, it is. I think that's a good question. So if there was sufficient utility in providing a convenience component, it might be something that the developers ship. I mean, it's open source, so you can file an enhancement request and provide the code yourself if you have a particular suggestion about how you think that might work. There are features that you can see now, and Dan was showing that some of the new features are pretty verbose, and we expect really some of the capabilities here to be exploited by frameworks. So you won't usually end up writing a lot of this boilerplate yourself, so you may be insulated from it unless you're a framework author. I hope that answers the question some.
Yep. Question from Ben Ashby. Will all the WebSocket code examples provided here work in Tomcat 7.0.47 plus with the backport?
In theory, yes. I haven't tested them on Tomcat 7.
Okay, great. There was a question from the earlier earlier segment that I thought was bear repeating. Stuart, please talk a little bit about when or if Tomcat will support Java 8.
Yeah, okay. So you can use Java 8 with Tomcat now, particularly in the cases of components that have a single faces other 8 features. The container itself is bound by the JE specifications, the requirements of the servlet spec to support Java 7, but there's no reason that in particular that you can't move forwards that I'm aware of. So do we support it now? The answer is probably yes. The best way to find that out is to try and build a small application that exploits some of the features of Java 8 that you're interested in.
Great, thank you so much. One other question from the previous session that I thought was worth repeating is, will TomEE include Tomcat 8 features?
I think you'd have to ask the TomEE developers, Dave Blevin and co., but I would imagine that they'll be looking to upgrade TomEE to Tomcat 8-based components as soon as they can, if they haven't done that already.
Fantastic. Since we are mentioning other vendors, I'm going to take a moment to do a little bit of a reminder to folks in that Pivotal does offer a commercially supported version of Tomcat that we call TC Server, as well as offering training, education services, and consulting around that. There's an email address on the screen if you're interested in learning more about how we offer developer production support, consulting services, and training. So please just email tomcat@gopivotal.com if you're more interested around that. And obviously we have some great people in the organization that help us. Folks like Stuart, folks like Daniel, and others. So I just wanted to make sure people are aware of that because I think, frankly, sometimes not everyone knows. Patrick Crocker asked...
Peter, one other thing to mention there is the support services that we sell help us fund people like Mark Thomas, who is a full-time Tomcat committer. That's his job. And so our contribution to open source is by employing people whose job it is to work on these projects. So it's kind of, people understand this isn't just money being thrown away, it's actually going straight back into the open source community in many ways.
Thank you very much for that. Yeah, excellent. Thank you very much for that. And I didn't realize that, actually, so I guess we all learned something today. Patrick Crocker asks a good question. DBCP2? Question mark. This is the first he's heard of this, and he can't find any release information. Is it publicly available on the Maven Central repository?
So Mark Thomas also works on some of the Apache Commons projects. The DBC2 packaging that we do is in Tomcat is a repackaging of the classes. I don't know whether DBC2 is actually independently released yet, but if Mark's included it in Tomcat, I would imagine it has been. Best thing to do would be to look at the Commons DBCP website for that information about which versions they're up to.
Okay,
gotcha.
So I was just going to add that I think what's been added so far has just been snapshots. So I don't know if there's actually a stable release yet.
Okay, got it. All right, folks, let's see. I think we've exhausted the question queue, and I think that also kind of exhausts, I think, some of the really good questions from the last segment. Maybe just one last one. There was a guy in the last session that asked if there was a plan to make Tomcats embeddable container like Jetty, and I just wanted to give you a chance to speak to that again because I think that's something else that people might not know.
Yes, in fact, the unit test I showed there uses runs an embedded. The mechanisms since Tomcat 6 had an embedded, and in Tomcat 7 this was modified to make it a slightly more elegant, easier to use solution, which is just called the Tomcat class. It's in Maven Central under the group coordinate org Apache Tomcat.embed, and yeah, you can use that right now. I encourage people to do that for their integration tests.
Excellent. Stuart, Daniel, thank you very much. Really appreciate your time and your dedication to material here. That's great. And I just wanted to let folks know, in case you missed it earlier on in the webinar, we do try to put out our webinar replays within 2 weeks. Often we do it much faster than that, frankly. And if you're interested in getting a notification about when those recordings are available, very simply, you could just subscribe to the spring.io/blog. There's an Atom feed there that you can subscribe to, and you'll get notified about the replay posts. Alternatively, you could just subscribe to the YouTube channel if you're more specifically interested in just videos, as the blog has lots of other blog entries and other types of content as well, in addition to the webinar replays. Also, would like to invite you on February 18th, Oliver Gierke and Thomas Derrimont, two of our key committers on the Spring Data project, are going to be talking about Spring Data repositories best practices, and take a look at how to do a very consistent interface-based programming model to allow a data access layer implementation for relational, NoSQL databases. We can talk about query DSL, a bunch of other things. So would love to invite you to that on February 18th. Also, if for the security-minded, we're going to be talking about, Matthias Arthurson is going to be talking about Spring LDAP 2.0 on March 18th. And if you liked what you saw in Stuart's demo about some of the Lambda usage and some of the Java 8 discussion, you may want to join our Spring Framework Hooler on March 25th as he talks about the Spring Framework 4.0 and Java 8 features and Java 8 usage. Again, that's on March 25th. So look forward to seeing you at a webinar upcoming. If you're looking for registration information for those webinars, they will be available on spring.io/blog. And I think that's pretty much it. Just want to remind folks that we offer that world-class support, training, and consulting on Tomcat. So just email tomcat@gopivotal.com if you're interested. And as Stuart pointed out, definitely helps fund the ongoing development and continued prevalence of Apache Tomcats. So thanks again for that, Stuart. That was great to learn. And any comments before we close it out, guys?
All good for me. Thanks, everyone.
Okay. Guys, thanks so much. Really appreciate it. And hope to see you folks on a webinar again really soon. Take care, everyone, and hope you have a great day. Bye.
Bye.